And we're going to talk about constant or uniformly accelerated motion under kinematics. Now, a body is said to be under constant or uniform acceleration if its velocity increases or decreases by equal amount in equal time. And so, the motion of an object that has a constant acceleration is referred to as a uniformly accelerated motion. Okay? We're taking this down. So based on constant acceleration of a body, there exists some simple relation between acceleration, velocity, distance, and time. Now suppose an object undergoes a uniform acceleration and its velocity increases from an initial value, say u, to a final value, say v. Now within a time t covering a distance s, now the uniform acceleration, which is a, will be given by the increase in the velocity over the time taken. So this is a, can as well write this as a equal v minus u over t. Okay, so if you do this, say we want to find the final velocity v now from this formula, we can cross multiply, right? We have v minus u equal at. Now if you take minus u over to the other side, you get v equal, let's say, u plus at. You can either write it as, even if I had written it as at plus u, it's still the same thing, okay? So we've been able to form a relation from constant acceleration. So let's call this equation 1. Now there are other equations of motion under this constant acceleration, but we would not need, there's no need to actually derive them, because in your exams you will not really be asked to derive them, okay? You just need to know them so that you can apply them while solving problems. So this is one of the equations of motion, and I'm sure you're familiar with it because you're a physics student. So we're going to take down the other 4. So this is 1. The next one is total distance that a body travels, and it is given as s equal ut plus 1 over 2 at squared. This, I'm sure it doesn't look strange to you. So the next one, let's say this is 2. The next one we have is s equal u plus v over 2, all in brackets t. So we also have v squared equal u2 plus 2as. Okay, this is 3, this is 4, right? Then we have the last one, s equal vt minus 1 over 2at squared. So this is 8. So these equations of motion, you can use them to solve questions. Take note that the acceleration could be positive or negative. Okay, for instance, if acceleration a is given as 10 meter per second square, the acceleration will be 10 meter per second square. However, if it is given as a now equal minus 10 meter per second square, then you can still say acceleration a is equal minus, you have to indicate it is equal minus 10 meter per second square. Or you can just simply say that the deceleration is 10 meter per second square. Deceleration is still acceleration, though it's just decreasing in the velocity, while acceleration is increasing in the velocity, right? Now, when motion under gravity is considered, you've heard of gravity, right? The 5 equations of motion that I have written, the first one will become V equal U plus or minus GT. Take note of the differences. I'm going to explain them as I go. Then the next one will be written as H equal U plus V over 2 times T. Then the other one will be H equal UT plus or minus 1 over 2GT square. This is 1, 2, 3. Okay, then the fourth one will be H equal VT plus or minus 1 over 2GT square. That's 4. We have 5 equations of motion, so it's remaining 1. Then the last one is going to be V square equal U square plus or minus 2GH. Now, because we are talking about gravity now, motion under gravity, you notice that your A, which is acceleration, you know, the first equation of motion that we gave was V equal U plus AT. Now, if you notice here, A here has been replaced with G. Why? Because that motion is said to be under gravity, and acceleration due to gravity is represented as G. So G is equal A. Take note of that, okay? So this mixed sign that we're having, minus, let me put that there, okay? So this mixed sign that we're having, plus minus, the plus sign indicates a downward motion. You know, gravity acts downwards towards the center of the earth. Now, while the negative sign indicates an upward motion against gravity. Okay, so that's just the difference. Now, for H, if you notice the other equation of motion that we gave that is not under gravity, we use S instead, right? So now this H here is representing or replacing the S, which is the distance. Height measures distance, right? So, and gravity takes place in a vertical direction. And so that vertical direction is the height that is measured. So that is why the H there, replacing S. Okay. So now when solving questions under the equations of uniformly accelerated motion, take note of this. There are possible cases we will need to take into consideration to help us avoid some set of confusions. And this is the trick to getting your correct answers. Most times questions will come and you may not understand the right equation of motion to apply. But with these cases, it becomes very easy. So the first one that we're going to see is if a problem, take note of this, you can jot this down now. If a problem states that a body started from rest, then its initial velocity, U, is always 0. This is for case 1. And the time t at this moment will always be 0 unless otherwise stated. Now, another case we can look at is if a problem states that a body comes to rest after being in motion for some period of time, or if it has to stop at a point and return in the opposite direction due to a constant deceleration, that is a decrease in its velocity. Let's say in the case of a stone, when you throw a stone upwards, it will definitely come down, okay? Now, at that moment, the final velocity V, is for another case, final velocity V at this point will always be 0. So please, you can jot this down and take note of it as I mentioned them. Now, another case is if a problem requires you to find the total distance covered in a certain journey, which is decelerating, or take note of that condition, decelerating, then you must set the final velocity again, V equal 0. Now, another case says that if a problem states that a body is being accelerated either from rest or from a certain velocity to another, the first velocity stated which is usually smaller in magnitude, must be treated as the initial velocity u, and the attained velocity after a certain time or end of the acceleration must be treated as the final velocity v. So lastly, if the problem states that a body is being decelerated, that if the problem you're asked to solve indicates that the body is being decelerating rather, or that say a brake was applied, the maximum velocity at that time when the deceleration started, that is when the velocity started decreasing, must be treated as the initial velocity u. That is u is the initial velocity. Let me put that down. And v is the final velocity. So, in this case, u is usually larger in magnitude, while the velocity attained at the end of the deceleration is treated as the final velocity v. And that final velocity in this case is always 0 again, unless otherwise stated for a certain period of time before the body comes to rest. So we are going to take an example to illustrate all that we've said. So let's take this question. If a car moving at a velocity of 20 meters per second, now the car is moving at a velocity, meaning its initial velocity is what is 20 meters per second. Now if this car with this velocity is brought to rest in time 10 seconds by the application of brakes, then according to one of the cases that we've gotten, we can get the acceleration of this body, okay? So let's try and solve that using one of the equations of motion that we stated. I hope you wrote that down. So we can use v equal u plus at to achieve this. So when we substitute our values, in this case, the car started from rest, right? So v, which is the final velocity, will be 0. And its initial velocity has already been given to us. So we have 20 plus acceleration is what we're asked to find. So t is 10a. Now when you take 20 to the other side, you have 0 minus 20 equal 10a. What do you do next here? You simply divide both sides by 10. So this is minus 20. 0 minus 20 is minus 20 equal 10a. When you divide both sides by 10, you get your acceleration a to be minus 2 meters per second square. Now you can see that this acceleration is having a minus sign, which is showing us that deceleration occurred, that is a reduction in the velocity. So we've gotten a equals minus 2 meters per second square. We would have been wrong if we had put minus, like in this formula now, this v equal u plus 80 would have been wrong if we put minus in the place of this plus sign, simply because we expect a deceleration, because the question said application of brakes. You'll be right in saying that is after your calculation that the deceleration is 2 meters per second square. You have to know how to interpret your motion, okay? But if you would have, or if we would have to use the value a, if we would have to use the value a in any subsequent calculation, it will be compulsory for us to use a as we have written equal minus 2 meters per second square. Else, you will misinterpret the motion of that object. I hope that is gotten. This kinematics is quite an interesting one. So we're going to take another question to show this. Now, let's say a proton, follow me closely now, a proton with an initial velocity of 10 meters, initial velocity u equal 10 meters per second square. Okay, 10 raised to the power of 5 meters per second, sorry. Velocity is meter per second. So if we have this, Now, a proton with an initial velocity of this enters an accelerating region and emerges with a final velocity v, which is equal 5 times 10 raised to the power of 8 meter per second after 10 seconds. That's time equals 10 seconds. How long is the accelerating region? In physics, you have to outline your parameters very well. If you do not do that, you tend to miss some steps, okay? So some of these things are like principles, rules that help us in physics. So we've gotten this now. How long is the accelerating region? Now the length of the accelerating region is equal to the distance covered during this acceleration. So meaning that if we're looking for how long the accelerating region is, it means that we're looking for the distance. Okay, so what we're going to use is one of the equations of motion, which is S equal ut plus 1 over 2 at squared. Or we can use S equal vt minus 1 over 2 at squared. Any of them you use is going to still give you the same answer, the same result. Alright, so all you have to do here is put in your values into the formula. So we're looking for distance S. But first of all, we need to get A. We have acceleration in this equation, right? So we need to get A first. So we apply the formula of average acceleration, which is A average equal V minus U over T, which is change in velocity over time. So when if you put in your values here, we already have our initial velocity and our final velocity. So you just need to put in your values and you get your answer. So doing this, we have V is 5 times 10 raised to the power of 8 minus 10 raised to the power of 5, which is the initial velocity, over the time is 10 seconds. So if you do that, you're going to get, you can calculate along with me. Collins, you're welcome to class. So to continue, if you do this, if you punch in your calculator, you're going to get average acceleration to be 4.999 times 10 raised to the power of 7. The unit is meter per second squared. So we've gotten one part of the question out of the way. We can use this to finish up. So if you substitute acceleration, let me put this formula down again. S equal ut plus 1 over 2 at squared. So if you put the value of average acceleration into this formula, you're going to get, we're looking for how long is the accelerating region. Do not forget, which is the distance. So our u is given to us as 10 raised to the power of 5 times time 10 plus 1 over 2 acceleration, which we got to be 4.999 times 10 raised to the power of 7 times t squared. So times 10 raised to the power squared. Right? So if you solve this, if you punch in your calculator, you're going to get this answer 2.500 times 10 raised to the power of 9 meters. Distance is measured in meters. Always remember to put your unit, guys. It's very important. Your grades can be reduced if you don't. Okay, so I hope we got that. Just for our own consumption, let's do this. I know I explained this in the last class. Okay, so let's just use this to warm up. You can take this down. The distance covered by a car at a time t is given by x equal 20t plus 6t raised to the power of 4. Let me write this as homework here. Alright, now the distance covered by a car at the time t is given by x equal 20t plus 6t raised to the power 4. Now the question says, calculate the instantaneous velocity and the instantaneous acceleration. It's easy. Just apply what we talked about in our last class. Okay, now the question still remains, calculate the instantaneous velocity and instantaneous acceleration when t equal 1 second. And that's that for that question. Hope you took that down, Johnson. Alright. So let's continue. Now let's take one more question before we run out of time to explain all the plenty things that I said about those cases. Let's see how we can apply them. Now, a body starts from rest and accelerates. Let's put that down. This is question. Now, a body starts from rest and accelerates uniformly in a straight line until it reaches a velocity of 40 meters per second in 8 seconds. Follow me closely. Now, it then travels uniformly, that is with a constant speed, for 12 seconds. This is another case of the question. Time t now equal 12 seconds. Now, it then travels uniformly for 12 seconds, after which it is uniformly retarded. You know what that means? It is reducing, decreasing, and brought to rest in 5 seconds. So this is another condition. So t equal 5 seconds. Don't get confused by the question already. You just need to understand the question. And if you know your formulas very well, you're good to go. In physics, that's just the thing. There's no big deal. So it's then brought to rest in 5 seconds. Now, calculate, number 1, the acceleration. Then the second is for us to calculate the retardation. Now, the last question here is for us to calculate the total distance covered in the entire motion. Okay? So, I trust we can do this. Let's go. Alright. So, solution. Now, the first case, we need to list out our parameters, right? Now, the first thing we were asked is to calculate the acceleration. Now, to do that, number 1, the body is set to start from rest, right? So, meaning its initial velocity, which is u, will be 0. Now, they said it accelerates uniformly in a straight line until it reaches a velocity of 40 meters per second in 8 seconds. So, our final velocity, v, is 40 meters per second at time t, which is equal 8 seconds. We can use one of the equations of motion to solve this very fast and easy. So let's apply v equal u plus at. We just need to put in our values. So we have v, which is the final velocity, to be 40, equal 0 plus 8a. If you do this, you get your acceleration a, divide both sides by 8, you have 5 meters per second squared. So we've been able to solve one part of the question. We've been able to get our acceleration, right? Now the next one is to find the retardation. I so much love that word. Okay, so the next one is to find the retardation. Okay, now let's go back to the question and understand it. properly. When the body is brought to rest, right, final velocity v will equal 0. So using this same equation of motion, which is v equal u plus at, we can get another relation that can help us in solving this. Now when the body is brought to rest, v is equal 0. Now using this, the question says, after which it is uniformly retarded and brought to rest in 5 seconds. So the time we are considering when the body started decreasing is 5 seconds, right? So when you put this into this formula, you get your answer, your retardation. So let's go. Now v here is 0, which is the final velocity, and our initial velocity is 40, plus acceleration is what we are looking for, but in this case, retardation. So t is 5, right? So 5a. Now, if you take 40 to the other side, you have 0 minus 40 equal 5a. This would give you minus 40 equal 5a. When you divide both sides by 5, you get a equal minus 8 meter per second squared. So we've gotten our retardation, right? The negative sign shows that the velocity is decreasing. So the acceleration is indeed a deceleration, or is indeed reducing, okay? Now, the last question, which is to find the total distance covered in the entire motion. This one is also easy to do, but we need to break the journey down one after the other. And the first stage of the journey, let's put it as first stage, the body starts from rest. So u here equals 0. And now the final velocity here was given to be 40 meter per second. And also the time t was given to be 8 seconds. So to get the distance of this first stage of the journey that the body started, okay, so you use s equal s1 now, because after we get each stage, the distance covered in each stage, and now we're going to sum all of them. That's just what that question is telling us to do. So when you do that, you have ut plus 1 over 2 at squared. If you put in your values here, you're going to get the right answer. So let's just do that. S1 equal, initial velocity is 0, right? 0 times t is 0 times 8 rather is 0. So, or let's just put it there, times 8, so some persons don't get confused, plus 1 over 2. Acceleration, we got our acceleration to be 5, if I'm not mistaken, 5, then multiply by the time t, which is 8, so 8 squared. So you have S1 equal, the final answer you get is 160 meters. So we've gotten the first distance covered by the body. Now to get the second distance, we see the second stage of the journey. Second stage. Now let's go back to our question. Now, after it reaches a velocity of 40 meters per second in 8 seconds, it then travels uniformly, that is under a constant speed, for 12 seconds. So it is safe for us to use our normal value, our normal speed. Speed is distance over time, right? Over time. We can get our distance here rather, Distance, you cross multiply, get your average speed. Let's put this as average speed here, guys. So average speed times time t. Now distance s, let's say s2, becomes this average speed times t. So here we get our speed is 40, right? It was given in the question. So 40 times 12 seconds. So the answer is equal to 480 meters. You can check that, all right, later. So we've gotten that. for the second stage of the journey. Now for the last stage of the journey, let's indicate the third stage, we have much time, which is S3, to find the distance covered at that stage. So we can still use S3 equal, we can still use this equation of motion ut plus 1 over 2at squared. But take note, we are going to use the values that affect the third stage. Now, after 12 seconds, after which it is uniformly retarded and brought to rest in 5 seconds. So now we are considering the retardation stage, where the body started reducing in velocity. So to do this, we say S3 equal the same thing, but in this case, 40 u, which is the initial velocity, times our time in this case was 5, so 5 seconds. Now it's no longer going to be plus because our retardation, we got minus 8 meters per second square, right? Our acceleration here under the retardation when we solved it was minus. So that automatically affects this positive sign, and we have a minus sign here. So this is 1 over 2 times 8 times 5 raised to the power square. So if you solve this, you're going to get 200 minus 100 equal 100 meters. So now the total distance covered is 160, which was the first stage, 160 plus the distance covered in the second stage, which we got to be 480, plus 100, which for this last stage here, 100. Now, if you sum this up, you are going to get 740 meters. And that is that. You can see that from understanding the question, we were able to get our correct answers. And now because of time, we are going to stop here for today. I hope you benefited from this class and you gained at least some knowledge on the equations of motion. And if you come across any problem, I'm sure it will not be an issue. If you have any problems, you can drop them in the platform, okay? So please always remind your friends, try and come early to class because it's really going to help you a lot. If you have problems in school also, you can always bring them to us. That is why we are here. We are here to help you guys have a stable and interesting stay. Okay? So it was nice having you. Thank you very much. In our next lesson, which is tomorrow, we are going to continue from where we stopped. Okay? And it promises to be very interesting. Alright. So see you in tomorrow's class.